this video we are going to discuss about design thinking based minimization techniques in digital electronics. Generally the Boolean expression has to be reduced based on the number of gates because we need a low power consumption for every devices, so that we are in need of power consumption in all the devices, which will be considered for a maximum number of input signals. So here we are having a lot of techniques which will be used to convert the number of devices or a number of power consumption into the devices, like Boolean algebra and Quine-McCluskey method and Karnaugh Map will be used to minimize the number of gates in logic gates, so that we can get the power consumption for all the devices as the same one. So let me see how this logic gate minimization has been done for design thinking 5 stages.
As I said, minimization techniques in digital electronics, which is aimed to reduce the complexity of the circuits. By reducing it also reduces the power consumption, cost, and several advantages will be boosted by using minimization techniques. Traditionally, there are 3 different techniques: Karnaugh Map, Boolean algebra, and Quine-McCluskey. By using design thinking concept, we can by integrating into our technology, we can also done this minimization techniques. There are 5 stages: empathy, define, ideate, prototype, and test. And now in the empathy part, the digital electronics context
We need to identify the problem statement of the concern Boolean expressions,
yes, sir.
so that we can choose which method we will going to consider.
Now that is the empathy part.
Yes.
There are many logical circuits in the digital electronics. In a specific digital circuit, it has more number of circuits to avoid complexity by reducing power consumption cost. For these criteria, we will be using minimization technique.
In the define part is like reframing the minimization problems. So it is to convert the problems into a problem statement. And also in digital electronics, it is beyond the logical functions.
Yes, logic like zeros and ones will be implemented for several number of inputs, like a binary conversion. So like that we can use this. Yes.
So the third part is Ideate, which is finding a problem, and we are sharing our ideas to find a solution.
So each engineer having some different ideas. So one of the best idea we can able to select for particular problems.
So like we said before, we have some manual minimization techniques in digital electronics, which are Karnaugh Map, Quine-McCluskey, and Boolean algebra, etc. So if we implement automations, like we have Python based minimization, and we have CAD tools like Xilinx, Vivada, etc. So we can also advance it by using AI and
so
ML.
These tools are using only for Boolean expressions and algebraic methods.
Yes, sir. We can also implement artificial and machine learning in this, sir. It will help us to simplify the problem and also
maximize the to reduce the power consumption as well as the maximize the efficiency.
For automation tasks, sir.
So the output is in order to build and develop minimized logic circuit. So the objective is to develop the initial circuit in order to test the feasibility, sir. So there are 2 types, original and minimized. So in order to check these things in Verilog we can use Xilinx, sir, and in hardware side we can use breadboard, sir. So
all the devices having input signal has to be tested by Xilinx models.
So we can
so built-in self-test is there, so that we can able to check the accuracy of the binary conversions.
So the output, in order to check these things, and the function, in order to check the function and implement
Once
it.
if you have got the original output, then we can
able to implement, sir.
Yes.
So once all the stages are completed, the last stage is testing stage. In this stage, the prototype was implemented in the real world applications, and in the testing stage we majorly test 3 things mainly. First one is logical accuracy, how it produces the output.
Because we are having gates, so based on the gates only we can able to consider the output. So if it is correct, then automatically we may go for next process.
And the second one is propagation delay. It relates to the time analysis of the circuit. And the third one is power efficiency. how much power is consumed by the prototype. So these things are tested in real-time tools like model sim, logism, and FPGA time analysis tools. So with the help of these, we can implement our prototype in the real world.
So based on the application, we can choose the softwares like PGA or Xilinx softwares.
Yes. Like as a conclusion, while we implementing the design thinking in the logical minimization techniques, it improves the traditional mathematical techniques more creative and innovative.
Okay. So thank you all.
Thank
Thank
you.
you.